All right, this is kind of a prerequisite. What I mean by that, this is something that's going to help us later on in this chapter. Okay, simplifying radical expressions. Now, some of you did this. If you had me or Mr. Stewart last year, you learned this. Okay, now if you had Miss Fike or if you were at Emmanuel, I'm not 100% sure if you saw this or not. Okay, so that is why we are spending time going over this week. This concept, we are going to simplify radicals as well as multiplying and dividing those radicals. We will not get to adding and subtracting. That's what Algebra 2 is for. Okay, this is just going to help us when we finally get into the chapter next week, solving a bunch of different problems. Okay, so we're going to refresh and maybe learn how to simplify radical expressions. So, starting off, I really hope you all know what the answer to A is. What's the square root of 36? 6. First of all, how do you know that's 6? Right, because square roots, remember, it wants whatever number times itself to get that number on the inside. Okay, so that's how we know the square root of 36 is 6. Now, B, is that as easy? No, why not? Right, there's not a number times itself to get us 45. Okay, there's no such thing. So this is where the simplifying comes in handy. Okay, now how I teach it is I want you to create 2 different radicals. We're going to treat the first one as the good radical and the second one as the bad radical. What classifies a radical to be anti-quote good? What do you mean by even? A perfect square, right? I have a list up here on the board. What is a perfect square that goes into 45? That's a factor of 45. It is 9. 9 times what gives you 45? 5. So 9 is my perfect square. And 5, I'm going to call it leftover. Okay. The reason I can do this is if I multiply these back together, do you agree that will get me back to the beginning? Okay. So now the last thing we have to do is simplify. Now, simplify the good. What's the square root of 9? 3. And then the bad, we just keep it on the end. Okay. So square root of 45 is the same thing as 3 square root of 5. All right. After those 2 examples, what I want you to do is I want you to list the perfect squares that I have up on the board on your paper just so that you have them. Okay. Again, how did I get that list? Like, yeah, 1 times 1, 2 times 2, all the way. I went all the way to 15 times 15. So go ahead and write all of those down. Okay, again, the biggest thing with these perfect squares is remember I had you make a good and bad. Okay, these perfect squares, their purpose is to break them apart into the good radical. So these perfect squares are the ones that go in the good. Do you agree there are more perfect squares after 225? Yes. Okay. I'm just not going to ever give you a problem where you have to go bigger than 225. Okay, so we're going to focus mostly on these 15 perfect squares. Before we get into examples, I want to give you the steps to simplifying radicals, and there's 3 steps. So go ahead and write these steps down. Step 1, first thing you're going to ask yourself, is it a perfect square? Okay. If it is a perfect square, like the square root of 36, is there anything you have to do with it? No, you just put your answer as 6, right? Okay, so if it is a perfect square, you just put your answer. If it's not a perfect square, that's when we have to go into these other steps. Okay, so if it's not a perfect square, step 2 is going to be to separate, or some of you are going to like to say split up. Okay, separate or split into, remember, the good and bad. Again, what numbers, or how do you know what goes in the good? The perfect squares. Yep. And then what did I call goes in the bad? Not a perfect square, it's what's over left over. So that's your step 2. And then what do you think step 3 is? Simplify. Yep. Step 3 is to simplify. And again, what I mean by that, simplify the good radical And what did we do with the bad? We kept the bad. Keep bad. Okay. Those are the 3 steps to simplifying radicals. Okay, again, simplifying the radicals, we're going to go through those 3 steps that I just had you write down. So what's step 1? Asking yourself, is it a perfect square? Yes, no? No, it's not. What's step 2? We split it up, right? Ask yourself what goes into it. So I split this up into good and bad. What's a perfect square that goes into 18? 9. How many times? 2. Again, just take 18 divided by 9 to figure out what needs to go in this one. And then step 3. Simplify. What's the square root of 9? 3. And then what do I do with the bad? Keep it. Yep. Okay. What about the square root of 125? Is that a perfect square? No. So we split it up. What is a perfect square that goes into 125? It is 25. How many times? 5. Okay. So what is the square root of 25? 5. Square root of 5. Good. Sorry. What's a perfect square that goes into 300? I heard 100. I'll go with it. How many times does 100 go into 300? 3. So now ask yourself, what's the square root of 100? 10. And then square root of 3. I'm going to stay on this example real quick. If I didn't pick, what's another perfect square that goes into 300? It is 25. So if I take square root of 25 times the square root of, how many times does it go in? 12. So now simplify this. What's the square root of 25? 5. And then we normally keep the bad, right?
Yeah.
Am I fully simplified?
No.
Why not?
Because 4 goes into 12.
Right. You know you're done when you can't simplify this any farther. Okay, but is there another perfect square that goes into 12? Yes. Don't forget we still have this 5 here. And then we split this up. What's a perfect square that goes into 12? 4, and it goes in 3 times. Good. Okay, again, don't forget about this whole number out in front. What's the square root of 4? 2. Then we keep the bad. So now what do you think I do with those whole numbers? Multiply 5 times 2. 10. Square root of 3. Again, not again. Why can I not distribute that 5 into the radical? They're not the same, right? I cannot combine a whole number with a radical to get square root of 15, for example. I cannot do that, okay? So, see how it doesn't really matter how you do it? What's going to help you get a quicker answer? You want to get the highest radical or the highest perfect square that goes into that number, okay? Because there wasn't anything wrong with picking 25, but did you have to do the process twice? Yes. Okay, so you always want to pick the highest perfect square that goes into that. Okay. Now, I understand it is a guess and check system right now. Okay, so go ahead and grab your calculator. I'm going to give you a little trick to narrow down your options. Okay, take your number 108, take that divided by 2. What do you get?
54.
Okay, 54. Look in your list. 54. Do you agree it falls between 49 and 64? Okay, so start with 49. Take 108 divided by 49. Does it work?
Nope.
No. So now take 108 divided by 36. You just keep working up the list. Does that work? Yes. What did you get?
36.
So this simplifies into 36 and how many times did it go in? 3. So now simplify. What's the square root of 36? 6. Square root of 3. Remember, you just simplify the good radical and you keep whatever's left. All right, again, first thing you ask, is it a perfect square, yes or no? No. So now, again, it's a guess and check game, but what eliminates some of your possibilities? What can give you a starting point? Right, take that number, divide by 2, start wherever that number falls in the list. So what did you guys get for a perfect square that goes into 192? 64. How many times? It off. It goes in 3 times? Okay. What's the square root of 64? 8. And then again, what do I do with this? Sometimes we get confused. I just keep that. Yep. Okay. What about 216? Is that a perfect square? No. What do I do? Divide by 2. Give yourself a starting point. What's the radical, or the perfect square? 36. How many times? 6. What do I do next? Yep, simplify. Square root of 36 is 6. What's left?
6.
Square root of 6. Yep. So now instead of just being given one radical, okay, we're being given 2, and we're asking to multiply them together. So biggest thing with this, I'm starting with 2 terms. I want to make 1 term out of that. So we're going to do that again by multiplying. So 2 radicals become 1, and then I just multiply the numbers on the inside. 6 times 8, 48. Okay. So I went from 2 radicals, created 1 big radical. Now we're back to simplifying. What's a perfect square that goes into 48?
4.
Higher. 16, how many times? 3 times. You could pick 4, but what would you have to do? You would have to simplify again, right? What's the square root of 16? 4, and then I keep the square root of 3. Okay. Again, on part B, I have 2 radicals. I want to make 1. What do? What does it become? Yep, multiply them together. I get square root of 100. Is that a perfect square? Yes. What's the square root of 100? 10. Okay. There's a little trick here. If you multiply the same radical times itself, you're going to be left with the number on the inside. And there's a little trick for you. And that will come in handy later. Okay. But, of course, you can go through the whole thing and then realize that too. Okay. So, let's look at a couple more examples. What's different about these 2 examples compared to the examples that we just did together? Some are already simplified. What else do you notice? Did we have a number in front before? No, that's the main difference. Here, there's not a number in front, but what can you assume is there? It's a 1, right? So go ahead and put a 1 in there. Okay. What I want you to think of right now, we talked about earlier, we cannot combine or multiply together whole numbers and radicals. Notice how they kept them separate here, okay? Because we can't put those together and make square root of 6 because they're not the same. Okay, so here I want you to think you're multiplying like terms. Okay, so do you agree 1 and 3 are like terms? Okay, they're both whole numbers. So multiply those together. What's 1 times 3? 3. And now multiply your radicals together. What's my new radical? 5 times 2 is 10. And then again, we're to the simplifying point. But is there a perfect square that goes into 10? No. So you're donezo. Okay, so let's look at number 2. Again, what number is technically in front of that square root of 6? A 1. So again, we're multiplying like terms together. What do I multiply together first? 1 times 4 is 4, and then I multiply square root of 6 times square root of 10 is square root of 60. Again, we're at the simplifying step, so keep this whole number there. A lot of us are going to forget about it, but we got to keep it the whole time. So that'll make your good and bad. What is a perfect square that goes into 60? 4, how many times? 15. Okay. Again, don't lose this 4 here. What's the square root of 4? 2. And then we do what with this? We keep that. Good. And then what's the last thing I got to do here? Multiply these 2 together to get 8 square root of 15. Again, is this like distributing here? Do I have to multiply that to the square root of 15? No, because they're not the same. If this was square root of 4, then would I multiply those together? Yes. Okay. Again, we're multiplying these radical expressions together. What do I need to do first? I want to go from 2 radicals to 1. If I combine those, what do I get? Square root of 18. Yep. After I multiply them together, what do? Simplify, right? I split it up. What is a perfect square? That goes into 18. 9, how many times? 2. So now simplify. What's the square root of 9? 3, and then I have square root of 2. All right, number 4, we have whole numbers involved. Again, if there's not a whole number, what can you assume is there? A 1. So what do I want to multiply together first? Negative 4 times 1 is? Negative 4. And then what's my new radical? 15 times 3 is 45. Okay, what do I do from here? Simplify. Don't forget that negative 4 out in front. We got to keep that. What's a perfect square that goes into 45? 9. How many times? 5. So again, simplify. What's the square root of 9? 3. And then keep square root of 5. Last thing we got to do. Multiply. We get negative 12 square root of 5. So dividing radical expressions is the same thing as rationalizing the denominator. Those of you that have seen this before, what is wrong with what we have right now? Okay, let's just focus on A right now. What's wrong with that expression? What can we not have? We can't have something. Correct. We cannot have a radical in the bottom. What I mean by that, we cannot have the square root in the bottom. So that's what we are going to do. We are going to rationalize the denominator. How can I get rid of that square root in the bottom? Here's a hint. I'm going to multiply by something.
15.
I'm going to multiply by itself. Square root of 3. But what I do at the bottom, I got to do to everything. Now, what I want you to understand about this example, okay? What if I divide square root of 3 divided by square root of 3, what is that? 1, right? So do you agree I'm not changing the value? Do you agree with that? Because if I multiply anything by 1, is it still going to stay the same?
Yeah.
Yes. So understand I'm not changing the value or anything. I'm just using this to simplify and get rid of the denominator. Okay? So now it turns into a multiplication problem. I'm going to multiply across on the top. What do I get? Square root of 15. On the bottom, if I multiply across, what do I get? Square root of 9. Yep. Okay. So now you simplify. Okay. Is there a perfect square that goes into the square root of 15? Nope. So that stays the square root of 15. What's the square root of 9? 3. Again, what are you going to be left with? That number on the inside, right? If you multiply a radical by itself, you're going to be left with that inside number. Okay. So this is your answer. A lot of you at some point are going to want to do this. You're going to want to divide this and get the square root of 5. Can I do that? Why not? Right. This would have to be in a radical in order to do that. Okay, but since one of them's a radical and one of them's a whole number, we cannot do this. Okay. All right, so taking that, looking at B, what do I need to multiply on B to get rid of that denominator? What do I have to multiply by? I have to multiply by that radical in the bottom. So I'm going to multiply by square root of 5 on top and bottom. So now you just multiply straight across. What happens when I multiply a whole number times a radical? Right, it just kind of squishes together. It gets 3 square root of 5. Keep in mind, this does not go to square root of 15. Don't do that. Okay. On the bottom, what do we get? Square root of 25. Okay. So now you're simplifying the top and the bottom separately. So looking here, can I do anything with 3 square root of 5? Nope. And then what is the square root of 25? 5. That is your answer. When you are dividing, you want to make sure that you can't simplify your whole numbers any farther. So for example, can I take 3 divided by 5? Or is there a number that goes into both? No. For an example, if I had 10 square root of 5 over 5, could I simplify these two right here? Because what's 10 divided by 5? 2, so that could turn into 2 square root of 5. Okay, so keep that in mind. You always want to pay attention to those whole numbers on the outside. Okay. So So looking at number 1, again, what's wrong with this is we have a radical in the bottom. So I want to get rid of that. What am I going to multiply by to get rid of it? Square root of 5 on the top and the bottom. So again, you're multiplying by whatever that radical is in the denominator. So multiplying straight across, what do I get on the top? Square root of 20. On the bottom, what do I get? Square root of 25. Make sure these are staying in radicals. Okay. What do I do from here? Simplify. Can I simplify the square root of 20? What's a perfect square that goes into 20? 4. How many times? 5. And then on the bottom, what's the square root of 25? 5. Am I done? Keep going, right? What's the square root of 4? 2. Keep the square root of 5 over 5. Can I do this? No, why not? Because it's not a radical. Yep. So this is your final answer there. Number 2, what am I going to multiply by to get rid of the radical? Square root of 2. Multiply straight across. What do I get? Square root of 6 over square root of 4. Can I simplify the square root of 6? No. What about the square root of 2? Square root of 4. 2. Again, can I say this equals the square root of 3? If I divide these, can I do that? No, because it's not a radical here. So this is your answer there. On number 3, what am I going to multiply by? Yep, that same radical that's in the denominator. So I'm going to multiply by square root of 3 on the top and the bottom. What's different about these, but we've seen them before, we have these whole numbers in front to think about. What do I get when I multiply the top? Yep, the whole numbers, keep that, and then square roots turn into square root of 6. On the bottom, square root of 3 times square root of 3, square root of 9. Can I simplify the top? Can I simplify the square root of 6? Nope, there's no perfect square that goes into 6. And then the bottom square root of 9 is 3. Done. All right. The reason I didn't have you do number 4 on your own is because it is a little different. What do you notice about the denominator now?
2.
Right, the denominator has a whole number now. That does not change what you're doing. Okay, you're still going to multiply by the radical. Okay, so what am I going to multiply on the top and the bottom? Just the square root of 3. Yep, I don't have to multiply by 2 square root of 3. I just have to multiply by that radical that's in the bottom. Okay. So again, it's the same thing. Multiply across on the top, what do I get? 3 square root of 12. On the bottom, what do I get? 2 square root of 9. Okay. Now we're simplifying. On the top, can I simplify the square root of 12?
4.
Right, what's a perfect square that goes into 12? 4. How many times? 3. On the bottom here, what's the square root of 9? 3. So there's a little more simplifying involved with this one. On the top, what's the square root of 4? 2. And again, I always keep the bad. On the bottom, I got 2 times 3. 6. What else can I do on the top there? Multiply these 2 whole numbers. So I get 6 square root of 3 over 6. Again, what did I tell you to always check for? The whole numbers here, what happens? They cancel, so I'm left with square root of 3. Done.